Okay, so now we're back. This is actually part 3, and we're on the back of the notes here, which is the reflections. Okay, so let's talk about what reflections are. Now, we defined it on the front. A reflection is basically a flip. Now, in this case, if we take a point, I'll call this A, and let's say I'm going to reflect it across this line. So if I'm above the line and I flip it, I'm going to end up below the line. If I was below the line and I reflected, I would end up above the line. This line is called a line of reflection. Now, there are 2 things to have a perfect reflection that we have to be able to do. When I count, I need to count straight to the line. And what I mean by that is I need to count as a perpendicular. If I'm above, if the line is horizontal like this, I'm going to count up and down. I'm not going to count left and right. So I need to find the distance between A and the line. Now in this case, I could just eyeball it, but let's say I'm going to use a ruler here. So if I count down, it's basically about 0.8 of a centimeter. So that means on the other side of the line, I need to count the same amount. So I'm going to count down to the line. I'm going to draw a little dotted line. And then I'm going to count 0.8 more on the other side. So I'm going to count down to here. That is A prime. Here's my pre-image. That's my starting. Here's my image. To be a good reflection, there's 2 things that we have to know. First of all, if I connect these 2 points, it has to be perpendicular to the line. It has to create a 90-degree angle. And the other thing that has to be true is the distance from A to the line must be equal to the distance from A prime to the line. These 2 points, A and A prime, must be equidistant. They must be equally the same amount of space from the line. Okay, so it has to be perpendicular. It has to create a right angle. Creates a right angle, which is perpendicular, and it has to be equidistant. Those are the things that we have to know. Okay, so let's say the point, here's A, here's our pre-image. Now we're to the right of the line. So to count perpendicular means we're going to count left horizontally. Now I'm just going to eyeball this. So whatever this distance is here needs to be the same on this side. Here's my point A prime. Okay, usually I'll just do a dotted line with that. I don't need to make it a solid line. So if it's to the right and I reflect it, now it's going to be on the left. Now let's say if it's a line that's slanted. To count the perpendicular, now we're looking kind of diagonally. Here's A. So again, whatever this distance is, I'll use the ruler this time. So that's about 1.5. So if I go another 1.5, that would take me to 3. Like that. There's A prime. Assuming these are equidistant and perpendicular, this is the reflection. If I turn it, that should look perpendicular. It's kind of close. Okay, so it should create 90, and it should be the same distance on both sides of the line. Okay, that's the key thing about reflections. Now, the nice thing is, we're going to do some examples here. On number 6, we can do a lot of this visually. So number 6 says, reflect point L, 5, -2, across the x-axis. We're going to do 3 things, part A, part B, part C. Across the x-axis, across the y-axis, and across the origin. If we go across the x-axis, here's the x-axis. Now that's horizontal. If we're below the line, that means we're going to flip it, reflect it, so that we're above the line. So I'm going to count how many spaces to get to the x-axis. So from here, 1, 2. That means I need to go 2 more spaces on the other side. 1, 2. Here's L prime. Now I'm going to label that, I'm going to put a little A there because that's for part A. The coordinates are 5, 2, the point of reflection. So here's L. If I reflect across the x-axis, I'm going up and then up 2 more. When you count, the point that you start at is not 1. It's when I make my first step. 1, 2, 1, 2. Part B, let's go across the y-axis. Now the y-axis is vertical, so if we're on the right side, we're going to go to the left. Again, I'm going to count straight to the line. 1, 2, 3, 4, 5 to get to the line. And then from here, 1, 2, 3, 4, 5. I'm going to call this L double prime. Okay, that's my second image from that. So that's for part B. Now those ordered pairs, that's -5, -2. -5, -2. The last one is across the origin. Now the origin is here at 0, 0. So if I take this point and I want to flip it over the origin, right now we're in the 4th quadrant. So if I flip this over, I'm going to end up in the 2nd quadrant. Now the thing is, we're going to need to be in the same position. So this is right 5 down 2. The same position here would be left 5 and up 2. So that's L triple prime, okay, or that's part C. That would be -5, 2. So in this case, if I connect it, notice that these are all going to be on the same line. Okay, not a good drawing, but you can see that you would go right through 0, 0. These would be the same distance. They would be equidistant if we've done this correctly. Now the other thing you can look for, they actually make a rectangle if you do this. If you go across the x-axis, the y-axis, and the origin, all 4 points will make a rectangle. Now one thing that you can also do, if you want to try to memorize a rule for this, you can say that, okay, here's my x comma y. The only thing that changed when I went across the x-axis, the 5 stayed the same, it was the y value that changed. The y value went from negative to positive. Okay, so the rule is that xy, when you go across the x-axis, it becomes x and the opposite of y. So if you were -2, now you're +2. If you were at +3, then you'd be at -3, your y value. If you go across the y-axis, what's going to change is the x value. Notice the y values don't change. They're still -2, but the x value goes from 5 to -5. So your xy becomes the opposite of xy. Now when you go across the origin, what happens is both x and y coordinates change. So when you go across the origin, xy becomes the opposite of x and the opposite of y. Now that may sound really confusing and you think, wow, I've got to memorize that? No, you don't, because you can just count it. Do it visually. That's, I think, the easiest way. So we're going to go from 6. Let's actually go down to number 9 here, because it says draw the reflection. We're going to do the same kind of reflection for triangle ABC, okay, which is graphed here. We're going to take the triangle, we're going to reflect across the x-axis, across the y-axis, and across the origin. So if we go across the x-axis, notice that we're above, so that means we're going to reflect it below. We're going to go down. So I'm going to take each point. Here's A. I'm going to count straight down to the line of reflection. 1, 2, 3, 4, 5. And then I have to count the same distance because the points will be equidistant. 1, 2, 3, 4, 5. And there's A prime right there. Here's point B. I'm going to count down 2 to get to the line, and then 2 more. And there's B prime. And then I'm going to do the same thing here from C. I'm going to count down 2 to get to the line, and then 2 more on the other side. There's C prime, and if I connect this, these should look congruent. This should be a reflection. So we took this and we flipped it upside down, basically. They're the same distance from the line of reflection, so this is good. This is part A, right here. So let's go back to triangle ABC. Now let's reflect across the y-axis. That's the vertical axis. So if we're on the left side, we're going to reflect it onto the right side. So we're going to take A. Now we're going to count to the right. 1, 2, 3, 4 to get to the line. So we have to go 1, 2, 3, 4 on the other side. There's A double prime. And then B, 1, 2, 3, 4. 1, 2, 3, 4. And then C, 1, 2 to get to the line of reflection, and then 2 more. There's C double prime. Connect the dots. And now this is the reflection across the y-axis. So this is for part B. Now the last one will go across the origin. So right now we're in the second quadrant. Across the origin, here's 0, 0. If we reflect it this way, it's going to put us into the fourth quadrant. So think of it in terms of positioning. For point A, instead of left 4, up 5, we're going to go right 4, down 5. Same position, just a different quadrant. B, instead of left 4 and up 2, we'll go right 4 and down 2. And then C, instead of left 2 and up 2, from 0, 0, we'll go right 2 and down 2. So this would be the reflection across the origin. And that is part C, right there. Okay, and that's the end of part 3 of the video. So we'll come back and do the last part.